You need to watch this if you struggle with optimizing your machine learning projects. Imagine you're a data scientist, or perhaps a machine learning enthusiast, eager to make a mark in this transformative field. Picture a world where machine learning is at the heart of innovation. From the self-driving cars that navigate our streets to the personalized recommendations on our devices, its presence is everywhere. But behind these marvels lies a challenging journey. This journey is known as the machine learning lifecycle, a series of intricate stages. Each stage, from defining the problem to deploying the model and monitoring its performance, is crucial. This lifecycle is the backbone of any successful machine learning project. Streamlining this process is not just beneficial, it's essential. An efficient lifecycle means faster development, fewer errors, and more successful outcomes. Think of it as a well-oiled machine, where every part works in harmony to produce the best results. In this narrative, we'll dive deep into the machine learning lifecycle. We'll uncover the common challenges at each stage, and then we'll introduce MLflow, a powerful open-source platform designed to simplify and optimize this journey. By the end of our story, you'll have a deeper understanding of how to navigate the ML landscape and build robust, impactful machine learning systems. Imagine embarking on a journey through a labyrinth where each twist and turn presents a new challenge. This is the essence of the machine learning lifecycle, a complex adventure filled with distinct stages, each demanding its own set of skills and strategies. At each stage, we encounter unique obstacles that require thoughtful navigation and meticulous planning. Let's embark on this journey together, exploring each stage in detail. 1. The quest begins. Problem definition and data collection. Our adventure starts with a clear mission. We must define the problem we aim to solve, setting the stage for our entire journey. Identifying the business objective and ensuring a machine learning solution is the right path is our first challenge. With our mission clear, we gather the essential data, the lifeblood of our solution. This data will train and evaluate our model, making it a vital step in our journey. The first hurdle, gathering high-quality data, can be a daunting task, often requiring significant effort. Data may be scattered, incomplete, or need extensive cleaning and pre-processing to be useful. 1. Preparing for the journey. Data preparation and feature engineering. Raw data is rarely ready for machine learning algorithms and must be prepared. This stage involves cleaning the data to ensure its quality and consistency. We handle missing values, outliers, and transform the data into a suitable format, ensuring it's ready for analysis. Feature engineering is another critical aspect of this stage. We select, transform, and create relevant features to improve the model's accuracy and performance. The second hurdle. This stage can be time-consuming and labor-intensive. It often requires significant domain expertise to engineer effective features that will enhance the model's predictive power. 1. Choosing the right path, model selection and training. With prepared data, we choose a suitable machine learning model that fits our problem. The choice depends on the nature of the problem and the characteristics of our data, requiring careful consideration. Once chosen, we train the model using our prepared data, allowing it to learn patterns and relationships within the data. The third hurdle. Selecting the right model and tuning its hyperparameters can be challenging and often involves trial and error. It often involves trial and error to find the best performing model, which can be a time-consuming process. 1. Evaluating the path, model evaluation and tuning. After training, it's crucial to evaluate the model's performance to ensure it meets our expectations. We use various metrics to assess how well our model generalizes to unseen data, ensuring its reliability. Based on the evaluation, we fine-tune our model's parameters or even revisit our feature engineering or model selection process to improve performance. The fourth hurdle. Selecting appropriate evaluation metrics and interpreting the results accurately requires a good understanding of statistical concepts and domain knowledge. 1. Reaching the destination, model deployment and monitoring. Once satisfied with our model's performance, we deploy it into a production environment where it can start making predictions. This might involve integrating it into an existing application or making it available via an API for broader use. Post-deployment, continuous monitoring is essential to ensure the model's performance doesn't degrade over time and remains reliable. The final hurdle. Deploying models can be technically complex and requires a robust infrastructure. Ensuring the model's scalability and reliability in a live environment requires careful planning and ongoing maintenance. Successfully navigating these stages is essential for any machine learning project to achieve its goals. However, managing this intricate workflow can become very challenging without the right tools and practices in place. This is where MLflow comes into play, providing a comprehensive platform to streamline the entire machine learning lifecycle. Once upon a time, in the bustling world of machine learning, there was a hero named MLflow. This open-source platform was crafted to be the guiding light for data scientists and engineers, helping them navigate the intricate maze of the machine learning lifecycle. Imagine MLflow as a magical toolbox, brimming with specialized instruments designed to build, manage, and track machine learning projects. Each tool in this enchanted box had a unique purpose, ensuring that every aspect of the workflow was meticulously handled. But MLflow was no ordinary tool. It was a platform-agnostic marvel, unbound by any single technology stack, ready to work with any machine learning library or language. Whether our heroes coded in Python, R, or any other language, MLflow seamlessly integrated into their workflow, making it a versatile ally in their quest for machine learning excellence. From Python with scikit-learn, TensorFlow, or PyTorch to R with its statistical packages, MLflow embraced them all, ensuring compatibility and flexibility for every project. Now, let's embark on a journey to discover the 4 magical components that made MLflow so powerful. 1. MLflow tracking. Picture a detailed logbook, chronicling every experiment in the land of machine learning. This logbook was more than just a record. It was a comprehensive history of their endeavors. MLflow tracking provided this meticulous logbook, capturing every detail of their experiments with precision. It recorded various parameters, code versions, metrics, and even artifacts like plots and models, ensuring that all information was at their fingertips. With MLflow tracking, our heroes could easily compare different runs of their experiments, reproduce past results, and collaborate with their team, fostering a collaborative environment where knowledge was shared and built upon. 1. MLflow projects. Think of MLflow projects as a standardized way to package and share their machine learning code. This standardization was crucial for maintaining consistency across different stages of their journey. It provided a consistent structure for their projects, making them reproducible and shareable, ensuring that their work could be easily understood and utilized by others. With MLflow projects, they could collaborate with others, run their code in different environments, and deploy their models with ease, adapting to various deployment scenarios. 1. MLflow models. This component focused on managing and deploying their trained machine learning models, ensuring that their models were always ready for deployment. It provided a standard format for packaging models, simplifying the deployment process. This made it easy to deploy them to various platforms, ensuring a smooth transition no matter where the model needed to run. Whether deploying to a simple server, cloud platforms like AWS SageMaker or Azure ML, or mobile devices, MLflow models had them covered, providing the versatility essential for modern machine learning applications. 1. MLflow Registry. Imagine a centralized hub where all their trained models were organized and versioned. This hub was the heart of their model management strategy. The MLflow Model Registry acted as a single source of truth for all their models. It allowed them to store, manage, and share their models within their organization, maintaining control over their models. With the Model Registry, they could easily track different versions of their models, deploy specific versions, and manage the model's lifecycle from staging to production and archiving, ensuring their models were always up to date and ready for deployment. With its powerful components, MLflow brought order to the often chaotic world of machine learning experimentation and deployment, providing a structured approach to managing the entire lifecycle of machine learning projects. It helped data scientists and machine learning engineers manage their projects more effectively, leading to faster iterations and more reliable models, ensuring they stayed competitive in the fast-paced world of machine learning. And so, with MLflow by their side, they ventured forth, confident in their ability to conquer any challenge the machine learning world threw their way. Picture this. You're a data scientist, diving into the world of machine learning. You run countless experiments, each with its own unique algorithms, parameters, and datasets. Every experiment tells a different story, with its own setup and results. But soon, chaos ensues. Your desk is a mess, papers and notes scattered everywhere. You feel overwhelmed, with no clear way to track your progress. Enter MLflow Tracking, your knight in shining armor. It offers a structured way to manage your experiments, bringing order to the chaos. Think of it as a meticulous record keeper, logging every essential detail of your experiments from parameters to results. Here's how MLflow Tracking becomes your best ally *, logging parameters. You can log any parameter used in your experiment, ensuring nothing slips through the cracks. This includes hyperparameters like learning rate, which can make or break your model's performance, the number of layers in your neural network, determining its complexity, or even the size of your dataset, which influences training time and accuracy. Having a centralized record of these parameters is like having a map, guiding you to understand why a particular model performs the way it does. Recording metrics. Metrics are the heartbeat of your model's performance, offering a clear measure of success. MLflow Tracking lets you log metrics like accuracy, precision recall, F1 score, and more, giving you a panoramic view of your model's performance. You can even log custom metrics tailored to your specific problem, making the tracking uniquely yours. This systematic tracking makes it a breeze to compare different experiments and choose the best performing model, saving you time and effort. Versioning code and data. Ever struggled to reproduce an old result because you couldn't remember which code version or dataset you used? It's a common dilemma. MLflow Tracking solves this by automatically logging the version of your code and data, ensuring everything is consistent. This means every experiment is tied to its specific code and data, making reproducibility a walk in the park. Visualizing results. Analyzing rows of numbers can be like searching for a needle in a haystack. MLflow Tracking lets you visualize your results with plots and graphs, making data analysis more intuitive and engaging. You can easily compare the performance of different models side by side, see how your metrics evolve over time, and spot trends. This helps you uncover insights that might be hidden in raw numbers. Collaborating with teammates. MLflow Tracking makes collaboration a breeze, fostering better teamwork. You can effortlessly share your experiment results with your team, promoting knowledge sharing. They can view the parameters, metrics, and experiment details, and even the code used, ensuring everyone is on the same page. This creates a collaborative environment where everyone can learn from each other's work, driving innovation. With MLflow Tracking, you can bid farewell to spreadsheet chaos and welcome organized, reproducible, and insightful machine learning experimentation. It's like having a lab notebook that automatically records everything, keeping your work organized and accessible, allowing you to focus on what truly matters, building better models and achieving success in your machine learning projects. Gap 2S. Now that we've mastered tracking our experiments with MLflow, let's take a step further. How do we transition from successful experiments to deploying our models in the real world? This is where MLflow models and MLflow registry come into play, acting as the bridge between experimentation and deployment. Gap 1S. MLflow models lets you package your machine learning models in a standardized format, making them easy to deploy across various platforms. Imagine this as a universal language for models, ensuring they can be understood and utilized anywhere, from cloud services to local environments. You can export your model with a single command, and it comes with built-in tools to serve the model as a REST API, simplifying the deployment process. Gap 1S. But the journey doesn't stop there. Enter MLflow Registry, your model's ultimate passport to production. The MLflow Registry is a centralized hub where you can manage the lifecycle of your models. It enables you to track model versions, Stage them for different environments like staging or production, and maintain a history of changes. This ensures that your models are always up to date and reliable. Gap 1S. With MLflow Registry, you can seamlessly transition from experimenting in notebooks to deploying robust models in production. You can also roll back to previous versions if something goes wrong, providing an added layer of safety. This transforms your machine learning workflow into a well-oiled machine, ready to tackle real-world challenges. Gap 2S. So whether you're a solo data scientist or part of a larger team, MLflow provides the tools to not only track and manage your experiments, but also to deploy and maintain your models effectively. It's like having a comprehensive toolkit that covers every aspect of the machine learning lifecycle, from inception to deployment. Gap 2S. Thank you for watching. Please subscribe to our channel, like this video, leave a comment, and share it with your friends. Your support helps us create more informative content to guide you on your machine learning journey. Gap 2S. Until next time, happy experimenting and deploying.